Good morning, everybody. Today we will discuss the other mechanisms in nucleophilic aromatic substitution reaction. So in the last class we have discussed the addition elimination reaction and elimination addition reaction, that is Benzene mechanism. Today we will discuss SN1 aromatic substitution reaction and SRN1 mechanism. So in SN1 aromatic substitution reaction, usually the diazonium salt and more substituted substrate is used, and it is a first order nucleophilic substitution reaction, and the reaction depend upon the nature of the substrate. We are usually using highly substituted benzene, and the substituent must be electron withdrawing in nature or diazonium salt. So this is the first example. Diazonium salt liberate nitrogen and to form aryl cation, and this cation react with nucleophile and to form the substituted compound. Now we are moving into the another example. In this example we can see that the benzene ring is substituted with electron withdrawing nitro group. There are two nitro group. As the electron withdrawing group increases, the rate of a reaction is also increases. Then there is one more substituent present in the ring, that is the chlorine. So in this reaction the nucleophile attack an electron poor aromatic molecule, resulting in a substitution of a leaving group. So nucleophile directly attack in the ring in which the chlorine is attached, because chlorine is act as a leaving group here, because chlorine is higher in size. That's why it is a better leaving group than that of NO2. And in the first step, carboanion is generated, and this carboanion is stabilized by electron withdrawing NO2 group. So the rate determination step is the attack of an aromatic ring by a nucleophile, which disturb the aromaticity of the ring, and the electron withdrawing group on the ring help to stabilize the negative charge of the intermediate. Then loss of the leaving group is not the rate determination step, and the fluorine is often used as a leaving group due to its high electronegativity. Now we are moving into another mechanism, SRN1, substitution radical nucleophilic unimolecular reaction. See the example. So the most of the reactions are radical reactions. So the radical, in which as in the case of the ordinary radical reaction, there is an initiation step and the propagation step. So in the initiation step, the radical is generated and that radical is propagated, and finally the radical liberate its electron to the starting material. This is the general mechanism of SRN1 mechanism. So see this example. Our starting material is ArN2 plus diazonium salt. It reacts with iodide ion, and the resulting reaction, overall reaction, is Ari plus N2 is generated. Then what is the mechanism? First of all, diazonium salt react with iodide ion and to form a radical. Both of them are exist in the radical state. This is the initiation step, in which the iodide ion transfer is its one electron to the diazonium salt. Then radical is generated, and this initiation step may be photochemical, or in the most electron loving starting material, it may be a thermal reaction. So the second step is the propagation step, in which the radical disproportionation occurs and to form the another radical and a neutral compound. Here the diazonium salt, it has a diazonium radical has a tendency to liberate nitrogen because nitrogen is a stable molecule. So that's why Ar radical is formed and nitrogen is liberated. In the next step in the propagation, this Ar radical which is generated in the propagation step again react with iodide ion and to form a arenyl radical anion, that is Ari radical anion. So here in this step a radical combine Ar radical combined with an iodide, that means it acts as a nucleophile, combined with a nucleophile and to form a radical anion. And in the last step, the radical anion liberate it one electron to the starting material and to form a neutral Ari and a radical anion. So in the last step, we can see that the radical anion liberate its electron to the starting material, that is diazonium salt, and to form a stable Ari and a radical anion itself. This is the general mechanism of the unimolecular SRN1 mechanism. Now we are moving into the general characteristic. First of all, this is a chain mechanism proceeding via radical. And the electron transfer may be photochemical or thermal electron transfer in the case of good electron acceptor and to give the radical anion. And in the next step, propagation step involves the dissociation of the radical anion and to give the radical. And in the next step, the radical couple with nucleophile and to give the new radical anion. And in the last step, the new radical anion transfer its electron to the starting material and to give the product and continue the reaction. I hope that you understood both the reaction. Now we finished the nucleophilic aromatic substitution reaction. Thank you.